In the course of the operational life of the electric motors, definitely there are one or more operational problems that will be encountered. So once this problem arises, we will need to rectify these problems and put the equipment or the electric motor back into service. So in this section or in this program, we are going to look at a few of those problems, the most common ones, and how to identify their causes with a view to rectifying or preventing them from reoccurring. And of course, we are going to look at some of these remedies. So you know that electric motors, in the course of their operations, they are subjected to different conditions. So these conditions, if they are too stringent or beyond what the electric motor can actually handle, they can cause this fault condition or cause problems on the operations of the electric motor. So when these problems arises, of course, our ability to be able to identify these problems and know what actually caused these problems, okay, will actually place us in a better position to better manage the electric motor and thus the electric motor system, improve the electric motor system reliability. Identifying a bad component in the electric motor is actually not enough, because when you identify a failed component, replace the failed component, the possibility of that failure to happen again will be there if the causes of the failure is not taken care of. So once we identify a failed component, it is very important for us to identify the cause or causes of this failure, so that we'll be able to put strategies in place that will prevent that failure from reoccurring. It is one thing to identify the component that failed, and it's another thing to isolate the cause of the component failure. We also want to know that for us to protect the equipment properly, that is the electric motor properly, we want to be able to identify these causes so that we'll put strategies in place that will help to eliminate that factor that contributed to the failure of the electric motor. So we are going to look at three different types of electric motor faults. The first one that we will be looking at is the internal fault. Okay, so the internal fault, when we say the internal fault, we are looking at the fault inside the electric motor, as you can see on your screen. So that concerns the winding, okay, that may result to winding failure. That concerns the bearing, that will eventually result to the failure of the electric motor itself, and then rotor problems, and of course the stator on which the winding is wound. So all of these constitute what we will term in this program the internal faults. Faults on problems with the winding, problem with the rotor, problem with the bearing, and problem with the stator itself. All of those, they are the internal fault, and any problem with these areas of the electric motor will actually affect the integrity of the electric motor and thus cause failure at the end. Then we are going to also look at external fault, or fault that are external to the motor itself. Okay, so in this case, we'll be looking at the power supply issues. That is the quality of our power supply. If it is not maintained, of course, it can affect the operations of the electric motor. Then single phasing, as we'll see later, okay, which is also a power supply issue, as we'll see later, can also affect the integrity of the operations of the electric motor. And of course, misalignment, that will eventually transfer all of those forces to the bearing, that can result to misalignment forces that will add up to the original load, okay, or the design load on the system, which will eventually result to overloading that can cause winding failure, or that can result to excessive load on the bearing that will result to misalignment, that can result also to rubbing of the rotor, which can cause winding burn, as we'll see later. So all of these are external factors that can affect the operations of the electric motor. Then environmental factor too, they can also contribute to electric motor failure. Okay, so the ambience on which the electric motor is operating is also very, very important, because these motors, as you see them, they are designed to operate efficiently in an ambience that is not above certain level. So if you are looking at such parameters as temperature and humidity, so each of these electric motors, they are designed not to operate beyond that level of ambience. So you will see that ambience will add up to the internal heat that is generated. If we are looking at temperature now, ambient temperature, will add up to the internal heat that will be generated by the winding itself. And that can result to overheating if that motor, the insulation of the motor is not designed to withstand that level of heat. Of course, that can result to failure. So there are times too, if the motor itself is not designed to operate in that environment with, say, high humidity, okay, so the possibility of water ingress will also be high. And once we have water ingress into the windings, we all know that it will reduce the insulating capacity of the insulating materials used on the winding, and thus result to winding failure that will result to the failure of the electric motor itself. So we want to be able to ascertain these different causes when they happen. Okay, once there is problem in the electric motor, there is a fault condition and the electric motor fail, it behoves on us to identify what has actually failed, whether the failure is internal, okay, and then what actually caused that failure, whether that the cause is from outside the electric motor itself or within the electric motor or from the environment. So once we are able to identify all of these causes, okay, we will now be able to identify remedies or solutions to these problems or causes, such that that problem may not or will not occur again once we have those remedies in place.